Hi roboticists! Today we're gonna make some fun with MoveIt, and in particular we are gonna create our configuration package for our robots for which we have the URDF file in MoveIt. So first of all, what MoveIt is? Well, MoveIt is simply a framework that works in ROS and ROS2, and this framework has been developed by a company named Picnic Robotics, who I have to say has done an outstanding work in creating and developing this package. Why that? Well, MoveIt, we can consider that it's a standard for operating with manipulation and integrate the vision system with the manipulation features of your robots. And without MoveIt, you should play with inverse kinematics algorithm, and you should go into the detail of mathematical domain, but thanks to this wonderful package, the manipulation and the integration with the camera and above all the simulation environment will be much easier. In fact, MoveIt contains, let's say, the state-of-art software for motion planning, manipulation, and three-dimensional 3D perception, kinematics, collision checking, control, and navigation. Now, for example, I can anticipate you, this is a Rviz visualization plugin in MoveIt framework, and you will see that at the DCP you can control easily, you can translate, you can rotate, and all the motion planning will be calculate and will be optimized automatically without go into the detail of the mathematical domain. And of course, now it's a matter to use this tool, because the purpose of in general ROS and MoveIt is that you don't need to reinvent the wheel. You don't need to create your inverse kinematic package, forward kinematics. You just need to select the solver for inverse kinematics, for example, and you just need to plug this tool and play right away. And I can assure you that it will be very, very useful, and I'm sure that you're gonna like this so much. So, before diving into the detail of this video, if you like this kind of video, make sure to subscribe to the channel, gives a thumbs up, and turn on the notification bell if you don't want to miss the next topic. So now, before to jump into the code and in our configuration environment in ROS, I just wanted to make to you an overview of what will be the behavior of MoveIt and the high-level programming that you need to know in order to orientate yourself in the usage of this wonderful package. So as you can see, there is this set of package. We can say that it's a very complex node that is called MoveIt, that you can see that is in the center. So it's considered to be the heart of MoveIt. And what does get as an input? Well, we can see that we have our robot controllers, okay, and there's a back and forward of interaction thanks to the joint trajectory action. I remember you that in the previous video we have configured our speed control manually, and we have created our specific controllers, and now you don't need to do that. So another input that it gets is the point cloud topic that we have seen in the last video from the robot 3D sensor that could be a 3D camera, the kinetic one, the one that we have plugged in the last video. And then we can have other kind of sensors from which Move group take the joint state topic, and of course there will be the robot state publisher node that calculate the transform, and I remember you that the transform keeps track of the position of each joint frame related to the frame of the robot over the time. Then from the ROS parameter server, MoveIt group takes the URDF file that model our robots. We have talked extensively with this URDF file and its chakra file. Then we have the semantic robot description format, which will be a file that will be automatically generated from the configuration of MoveIt. And then we're gonna have a config, same story that will be generated automatically. And then here we have a set of let's say a file and a package that we will program in C++ and in Python. So what we will do is to program a pick and place or any kind of manipulation purpose for our robots in this user interface. MoveIt provide a user interface, and we will need to use the object of C++ and Python, and of course we're gonna have a GUI that is gonna be a Rviz plugin, and each group interface and MoveIt commander will interact with the MoveIt group with some action, for example the move group action, the pick and place action, and so on and so forth. I not want to go into the detail right now, but I just wanted to show you the architecture of MoveIt, which will be very important in order to do not make any confusion. The key takeaway here is that MoveIt is a really complex framework, and you just need to provide the URDF file, set up the robot 3D sensors, and then you will need to play in C++ or in Python with the code and with the object embedded in the C++ package and the Python package. Okay, after this introduction we are ready to configure our robot in MoveIt. So we're gonna create the MoveIt package for our robot that we have modeled and for which we have the URDF file. So first of all, if you don't have it, you need to download the MoveIt. So you need to type sudo apt get, then install, then as every package that you need to install, you just need to type ROS robotic, then MoveIt, then again ROS robotic, MoveIt, then plugins, then ROS again robotic, planners. Okay, so enter, type your credential. Of course, here is very straightforward and very quickly because I have already installed in my computer, but I just wanted to let you know that the first time it might take a while. Okay, so now you just need to open our configuration assistant tool. So what we will need is to launch the setup system, and what we're gonna do, so it's we need to kick off our launch file. So ROS launch, then the name of the package, that is gonna be MoveIt setup assistant, and then setup assistant.launch. Get the help of the auto compilation. Okay, and here you go. Now you can see that we have our setup assistant, and now we just need to follow the pathway, which is really straightforward. First of all, you need to give as an input the URDF file. So you just need to create a new MoveIt configuration package, load the URDF file. So let's navigate to the browser and let's go home, Catkin workspace, SRC, then cobot simulation, then we have RDF file, and we are gonna plug in the cobot underscore camera shape profile. And if it doesn't work for you, it means that this setup assistant doesn't accept the URDF extension. So just remember to change the name and put it as a chakra extension. So let's do it, and click load file, and here you are. Do you recognize it? Is our robots. Okay, so this is our access robot, the base link, link 1, link 2, link 3, link 4, link 5, the TCP connector, and then the two grippers, and here the camera plugin, the kinetic one that we have installed in the last video. So then let's go for the self collision, and this is really important. So if you generate a collision matrix, what it is, well, when you disable it, you simply disable the checking of the collision between each link. So if you deactivate, it will takes a lot of time for generate and calculate the inverse kinematics. So for example, this is the link 3, that is gonna be this one. there's no way to have a collision with the link 2, okay, because they are attached between each other at the edge, so there's no way. But it is important to do not disable the check of collision from link 3 and link 1, because this could definitely collide. Here virtual joint we don't need to have. Here, for example, if you mount this robot in a mobile robot, you just need to fix this robot into ODOM, for example, but this won't be our case because it's directly attached to the world, let's say. So then this is a key for the setup assistant. So you just need to add the group, and we are going to create two groups, the one of the arm and the one of the gripper, very important. So let's type add, and then we create a group that is going to be arm, okay, kinematic solver. Here there is the solver algorithm that you need to select. We can use this one, is the standard one, I would say. Just keep this data, and then we can select the OMPL planning. What OMPL planning stand for? It stands for Open Motion Planning Library. What does it mean? That the Move group nodes talk to the Motion Planner plugin via the ROS action and server, as we said in the previous slide. And the default planner library used by MoveIt is this one, Open Motion Planning Library. And the default planner, we can select RRT, that stands for Rapidly Exploring Random Tree. And then, this is very important, after that we have set up our kinematic solver and the motion planning algorithm, then we need to assign to which group of our robot will have this parameter. So since that the arm is from the base link to the TCP connector, okay, this is a kinematic chain. So instead of add all the joints, we can add a kinematic chain. And then let's explode everything here. Gripper connector, okay. So this is our kinematic chain, and the base link will be this one, and then so choose selected this link, and then the tip link, the end of our kinematic chain, will be the gripper connector, and choose selected. Then save. And what we're gonna do, we're gonna do the same for the gripper, and the gripper will be only the gripper left and gripper right. So we're gonna add a group, another one, and now let's call it gripper. Then add the kinematic solver, then add our rapidly exploring random tree motion planning algorithm, and then we just need to add a joint, and the joint will be the gripper left and the gripper right. So let's add, and it's done. Save. Here you are. So we have created two groups one is called arm and one is called gripper, and for each group we have assigned a kinetic solver and a motion planning algorithm. This will be very important. Then robot pose, and you can add a pose, a standard one for example. This will be very useful when you're gonna play with the Rviz, so we can save already a certain position of each joint. So we can keep this one and we can call it let's say the zero position. Okay, then we can save. Okay, and then for example, since that this robot is designed for pick and place purpose, we could select a home that will be the ready to pick and place. So usually, this we can keep it 0. Usually when it's ready for picking, our robot will have this shape here. Okay, this one we can just rise a little bit. Okay, so imagine that there will be a beam picking application. The box will be here and this will be the position ready for picking. Okay, let's save it and just continuing. Now we are gonna add an end effector, which will be very useful when we are gonna play with Rviz reconfigure. So we are gonna have in Rviz configuration GUI some arrows that will be very useful for translate and rotate the end effector, and all the robots will move accordingly. So let's add an end effector, and we can call it robot end effector. Okay, then the group name will be the arm, and the parent link will be the gripper connector, because the TCP or end effector will be attached to the parent link. So make sure that the definition of end effector will be like this. Then let's go ahead, and passive joint will not be our case. The passive joint is the joint that doesn't take part to the kinematic solution of your of the movement of your robot. Imagine, for example, that you have a mobile robot driven by 2 wheels, and you're gonna have in the middle a caster ball, and if you think that caster ball doesn't make any action, it just move accordingly. So since that we're not playing for the moment with the mobile robots, we just skip this. So now is the setup controller. And if you remember, we have made a course for setup a custom controller, but for now just use the one that will be automatically generated. And as I remember, it will use the follow joint trajectory action control. So let's auto generate it, and here you go. it's auto-generated. So for each joint, if you wanna go deeper in this section, for example, there will be a critical joint that in your opinion will need a custom controller. You just need to select the joint that you want to control specifically and add a controller. But for now, let's keep things easy. So simulation, 3D perception. For the moment, just don't put the 3D perception. We're gonna put it later. And so author information, this is important and mandatory. And so the name will be Learn Robotics with Ross, and just put your name, your mail if you want to reach out. It can be a fantasy email, but I would suggest you to put a real one. So I'm gonna put I'm gonna put the mail that is assigned to this channel, Learn Robotics with Ross. By the way, feel free to reach me out if you have any question about this topic and Ross topic in general. Configuration file. Okay, now what you will need is to assign a path for the package that is going to create automatically. So let's browse, and I'm gonna put src. I'm gonna put in the source file, so I can select I can create another one, and I'm gonna call cobots MoveIt config, which will be our package, the name of the package. Let's select this, and we should have done everything. So this will be the list of the file that will be automatically generated. So generate the package. No virtual join have been added. Okay, I have already explained you why. So let's click OK, and it's automatically done. So you can exit the setup assistant. Okay, and now you will see a real magic. So let's open our Rviz demo for our robots. So let's type ROS launch, the name of the package that will be cobot MoveIt config, then demo.launch. This is a demo launch file that is automatically generated from the configuration, and here we go. You can see here we have our TCP that we can control, okay, very easily with this translation and rotation features, and planning group arm, and we can select the grip arm, etc. Then what we can do is we have the start state, which is the current one, the 0, and the goal states. For example, here there will be the position that we have saved in our setup assistant. So for example, if we click home, this is a preview, and then you can plan or plan and execute. So if you click plan, you will see with the plan the motion planning algorithm is going to work, and it show you the pathway and the trajectory that our robots will do for moving the robot from a start position to the goal one, and then we can execute. Then it's done. Here, for example, if we rotate this one, then for example, if we move here, you can see, then we click plan and execute, and you will see here that it will change the pathway. And again here I can rotate I can go up and rotate this and go translate in this direction. Let's plan and execute. You can see this has to make this pathway in order to get a collision with each link. Okay, don't worry about that. We are gonna talk about MoveIt extensively in the upcoming video. But this video has the purpose to introduce you to MoveIt, make the configuration package for your robot that you have designed, for which you have URDF, and show you some key feature of Rviz playing with this demo. So that's all for today. I hope that you enjoyed this video. If you like this video, make sure to subscribe to the channel, and in order to give me also a little bit of motivation to continue this series of tutorial with ROS, and in particular with the manipulation for industrial purposes. And I'm looking forward to see you in the next video, where we are gonna play with MoveIt extensively. We are gonna use Rviz for MoveIt, and so on and so forth. And as always, keep learning robotics with ROS.